Okay, so today we're going to talk about function notation. Yesterday we just talked about functions and relations. Now we're going to talk about how functions are written in the notation. So with function notation, what we do is a function notation is an easy and efficient way to name a function that is described by an equation. So in other words, we're going to take an equation and write it in a different way. For an equation using x and y, the symbol f of x, this is our most common way to indicate a function, replaces the y and is read f of x. Hold on a second. So it is read f of x. That's how we read it. Okay, so right here I read it f of x. Now it looks like you're multiplying, but it does not mean f times x. It does not mean that. Does not mean that. Okay, so for example, if I have the equation y is equal to 2x plus 1, my function, that's the equation form. This is how I write it as an equation. If I write it as a function, the only difference you'll see is that y becomes f of x. Okay? Now, you might be wondering, why do we do this? Well, it helps us to relate the the function rule to its graph. Okay, so when we're graphing, we can then indicate which graph we're talking about by the function letter. So each solution, which is an ordered pair, okay, each solution to the function represents a point that falls on the function, that is on the graph of that function. Okay, does function notation always have to be expressed as f of x? No, that's just the most common. We can use any letter to represent. So we can have g of x is also very common. We will have h of t. Okay, so we'll have it lots of different ways. And what that means is that we are comparing multiple functions and their graphs, or their graphs. You need some way to distinguish them. So you'll see on the next page that I think it's h of t is what we use. G of x is common. F of x is just the most common way we write it, but all of those mean functions. So evaluating functions is also easy. No matter what people tell you, functions are not hard. Okay, so if we consider the equation y equals 3x minus 8, if we want to write it as a function, guess what we do, guys? Yeah, it's easy as just changing the y to be f of x. Now I have a function. Equation, function, equation, function. And the only difference is that f of x. That is our only difference. Okay, so now, suppose you want to find the value of the output. Okay, this is all mathematical words. We'll get to it. Don't worry. That corresponds to the input of 5. So in other words, typically that would be our y, and we want to put in, that would be our x value, 5. In other words, you want to evaluate if x equals 5. So that's what we're going to, then it is written as f of 5, okay? And it is read, oh, sorry, I already did that for you, read as f of 5. Or you can read it as, what is the value of the function at 5? Or what is the value of the function at 5 is what it's asking. The value f of 5 is found by, you can probably guess, yeah, we're just going to plug it in. We're going to substitute that value in. Substitute 5 for x into the equation. Hint, make sure to use the order of operations. Okay. So in other words, you're basically going to be solving. No, you're not going to solve. You're going to simplify an equation that's one-sided. It's all going to be on one side. So it's really kind of nice. It's used a lot in science because then we can just plug things and it just makes it a little more convenient. So say, for instance, we have this. We have f of x is equal to 3x minus 8. We're going to find f of 5. So that means that in place of x, I'm going to put a 5. And I would recommend putting it in parentheses. But notice all we did. See how I have an x and here I have a 5. So here when I have an x, I plug in a 5. So wherever I see x, that variable, I'm going to plug in the number. So now I just simplify that. 3 times 5 is 15 minus 8 is 7. So what that means is f of 5 is equal to 7. Or the function at 5 is equal to 7, or the x value is 5 and the y value is 7. Those all mean the same thing. We can take this function and do another one. Let's do f of negative 2. Let's find f of negative 2. Try it. Go. Did you get negative 14? Great, because all you did is you take negative 2 and I plug it in place of x. See how those are both x's? I just this time plugged in a negative 2. So I can find the function value at any place they give me an x value for. I can find the function value. Okay, so here we go. You're going to try these two right now. Ready, set, go. So if you found g of negative 3, you would have got negative 6, and f of negative 1 is 1. Okay, so let's actually go through the steps on how we do that. So I want to find g of 3. I'm going to use different colors to just kind of emphasize where everything's going. So now I'm going to take 3 minus 3 squared. So see how I just took wherever the x's were, and I'm going to put a 3 in, because they told me I had to find g of, negative 3. Find g of negative 3. Okay, so now I'm just going to simplify that, and I get 3 minus negative 3 squared. A negative squared is positive. 3 times 3 is 9. So I get negative 6. Okay, let's do the same thing over here. So I'm going to find f of. So now I want to find f of negative 1. But I'm going to plug it into this function. All the function stays the same. It's just that wherever I see x, I'm going to replace it with negative 1. So I'm going to replace it with negative 1. I just put that in because that's what they told me. So we get negative 6 plus 7, which is 1. Okay, should we try one more? Since we have those two functions, let's do another one of those. I want you to find g of 2. Go. Hopefully you found out that when you plugged it all in, you got negative 1. Let's do that. So here we go. We're going to take g of, and we're just going to plug it in. Okay, and now I'm finding g of 2. So in place of x, I have a 2. And wherever I see x, I'm going to put a 2. So I have 3 minus 2 squared is 4. 3 minus 4 is negative 1. Okay. Now on the back, we're going to do some real-world functions. Oh, and yes, it was h of t on the back. This is a physics problem, so when you get into physics, probably your sophomore or junior year, you're going to take physics. And this is all about the height of a ball and everything else, and its trajectory. So it's trajectory, not just a ball of anything. We can use this function, h of t is equal to negative 16t squared plus 48t, to represent the height of a ball thrown in the air over time. We would say that the height of the ball h is a function of the time, because this is h of t. H of t is how we'd read it, and what that means is that height is a function of time. That's what we're finding here. And that's the other reason that we like to use function notation, is because we can symbolize it very quickly. Height as a function of time is right there. It's very easy and very quick to symbolize it. Okay? So we're going to look at the following function that shows the cost. So this is just an example. We didn't even find one. We could have plugged in information, but for some reason, we're not going to. Okay? Let's look at the following function that shows the total cost C, at an amusement park. Okay, so the cost is C. That is our cost. Depending on the number of tickets bought, T. So that's the number of tickets. Okay, and here's our function. We can evaluate this function for T equals 5. What does that mean? This is 5 tickets. So we're just going to plug that in. So we can find C of 5. The cost of 5 tickets. Watch me again. Cost of 5 tickets, because what's inside here stands for tickets. So now we're just going to plug that in. C of 5 is equal to, so again, you can just write out your function, and wherever you see the variable, leave a parentheses. Now here, that number's in the parentheses. It goes in the parentheses here. So 5 is what we're plugging in to our function. So we get 10 plus 3, which is 13. So what does that mean? So our output is C of 5 is 13. What that means is that 5 tickets cost $13. 5 tickets cost $13. So now let's try that exact same function for C of 10. What does the 10 stand for? Again, that's the number of tickets, okay? So let's find C of 10. Go. Okay, so hopefully you found out that C of 10 was equal to 23 because I plugged the 10 in. I'm going to multiply and then add. Okay, well, what does that mean? What does that mean? It means that you have 10 tickets, because remember our original function, cost of the number of, depending on the number of tickets, okay? So what's the cost? That depends on the number of tickets, okay? So what does it mean? That 10 tickets cost $23, okay? Questions? Good. So that is the lesson for today, and you'll go out to Schoology and find out what your assignment is. Great. If you have questions, you know where to find us.